So for my physical science project, I made a steam-powered boat. So first I'm gonna show you my materials. You need a small jar candle, milk carton, ruler, cutting materials, marker, soda can, straws, and tack it. So first you want to empty the soda can. You can wash it also after to make sure it's clean. And then next you would like to cut off the ends using the cutter. Both ends so that it'll look something like this. Then cut it through the middle so that it becomes a flat surface. Next, you want to make it as rectangular as possible, so you just cut off some of the edges. You could also fold it in half first and then cut off the excess afterwards. Next, you want to measure 1 centimeter per side, so that's both left, right, and up. Then you want to cut the sides off until the half fold. So the strips are going to be cut off. And you can cut off the top part as well. Next, you take your tacket and you roll it up and you put it on the sides of the smaller rectangle. And you fold it in and you press, but then you don't press too much because you want space in there for water. Next, you put more tacket on the sides, on top of the smaller rectangle, so that you can fold the side strips inwards, like so. Use pliers to make sure it's really, really tight. There has to be no holes for air. Cut off the excess on both sides. Get some more tacket, roll it up, and flatten it so that it looks like that. Roll your straws up in this and it should look something like that. Use the rest and put it inside your soda can engine. Put it on top and bottom. To fill up the space so that when you put the straws in, there's as little space as possible. So it snugly fit, you know. Cut off the sides so that you can fold it inwards. They stack it again. Next, you want to cut up your carton into a box that looks like that. Mark the area where you want to put the straws in the carton and cut it up with a cutter. Make sure it's not too big so that it also snugly fits. Next, put some water in your engine by using a smaller straw and inserting it in the straws of the engine. Next, insert the engine into your boat and use tack it to close any other holes. Make sure it's snugly fit. Next, tape the straws to the back of your boat. Make sure it goes forward. Next, do a floating test and a measuring test. Make sure that the boat can carry the weight of the engine, the candle, and the coin, and for my experiment, it has to reach at least 10 centimeters. Light the candle up using a lighter and put it under your engine so that it will heat up the water inside. So it should look something like this. Once your water is heated, you can try floating your boat. In this trial, I think it's more of the current of the water moving the boat. So make sure that the water is as still as possible, or that the power of the boat is strong enough to go against the current. Trial number 2 looks better. It only moves forward instead of circular. And that is more than 10 centimeters. Trial number 3, we tried to face it the other way so that you'd really know that it's the engine moving, not anything else like wind or current. And it worked. If you listen closely, you can hear the put of the boat, which means that water is being sucked in and released. So this is basically how the boat moves, and I will be explaining further with animation. Okay, so basically the water is heated up until it boils and evaporates, producing steam. Now the steam expands not only due to phase change from liquid to gas, but also because it is still being heated. So that creates high pressure within the boiler, causing it to push the water out the straws and allowing the boat to move forward. Once the steam in the hot water is pushed out the straws, there is very low pressure within the boiler, causing it to suck water because particles generally grow from higher pressure to lower pressure. The newly sucked water is heated again and the cycle continues until the heat source is removed.